Hello students, welcome to JCE Connect. Subject Groundwater and Hydraulics 17 CV 742. In previous class we have seen what is aquifer, what are the different types of aquifer, that is confined and unconfined aquifer, and the types. In today's class, we will discuss the occurrence of groundwater in different terrains, like different types of rocks, how the groundwater occurs. So, as we all know, rocks are the aggregates of minerals. Different minerals are present in a rock, and there are three types of rocks mainly, that is igneous rocks, sedimentary rocks, and the metamorphic rocks. So igneous rocks are formed by cooling and consolidation of magma and lava. Then sedimentary rocks are formed by the deposition of sediments. Then later they are converted into a rock by different processes like cementation, compaction, and finally the lithification. So this is how the sedimentary rocks are formed, by sediments. And the last type of rock is metamorphic rocks, that is formed by the effect of high temperature, pressure, and sometimes chemically active fluids. The already existing rocks, they undergo changes because of these factors, and the new rock is formed, that we call it as the metamorphic rock. So these rocks, they show a great variation in their water bearing properties. So because of the different mineral content, different mode of formation, so they show the different properties also, that is water bearing properties, and also the physical and chemical properties of each rocks are different. So these rocks show a great variation in their water bearing properties. So some groundwater occurs in most geological formations, because nearly all the rocks in the uppermost part of the earth's crust of whatever may be the type or the origin or the age possesses opening called the pores or the voids. Means what? Some groundwater, some quantity of groundwater we find in almost all type of geological formations, nearly in the all rocks in the uppermost part of the earth crust. Okay, at certain depth in the uppermost part of the earth's crust, we will find water in all types of rocks. Why? Because these rocks are weathered rocks on the surface, and because of that they possess openings which are called as pores or voids, okay, on the surface. So that is why some amount of groundwater is found in all the types of rocks. Then the several factors, they relate to the occurrence and the movement of groundwater, like there are many factors like porosity, permeability. So these are the factors which affect the occurrence and movement of the groundwater. So in detail we will discuss what is porosity and permeability in the further class. So first we'll see how the groundwater occurs in weathered rocks. So I hope you remember what is weathering. So weathering is the disintegration and decomposition of the rocks. So what happens to those rocks? Because of the action of temperature, water, then pressure, all these rocks, they undergo a process called weathering, wherein the rocks break down. Okay, sometimes rocks undergo, there are different types of weatherings, like physical weathering, then chemical weathering, and sometimes the rocks undergo biological weathering also. So these weathered rocks, they are the good source of water. Like here in the images I have shown, the different ways in which the rocks undergo weathering, how it looks exactly. Okay, so in the first image, the bedrock. Okay, here you can see there are this is just a model wherein you can see n number of cracks here, and the water is present in those cracks. Water is moving down into those cracks, and here this is especially in the limestone region. Here it is written limestone, right? So in limestone there is a special case wherein it forms caves like this inside the rock. Why? Because limestone is a chemically reactive rock. Okay, its composition is calcium carbonate, that is CaCO3, and because of this, what happens, the rocks undergo weathering. It starts dissolving because the water which is percolating down, it will have some dissolved minerals in it, so it will react with the calcium carbonate and the rocks undergo weathering. Okay, the sinkholes are the common structures which are seen in the limestone region. Okay, then this type of caves in which you can find the stalactites and stalagmites. Okay, then columns, all these structures are seen in the limestone region, and this is why they are the good reservoirs of the groundwater. So you will find groundwater in such rocks in a good amount or good quantity. So here this is how the effect of weathering you can see on the rocks, right? The rocks show the cracks. Okay, so on this is how the profile looks like. Okay, at the bottom you will find the fresh bedrock. Okay, and on the top slowly the weathering decreases from top to bottom. So this is how weathering looks like, weathered rocks. Okay, these are the layered rocks which have undergone weathering. This is a effect of chemical weathering. We call it as honeycomb structure, right? Then these type of weatherings are seen because of the wind erosion. Okay, differential wind erosion will result into formation of these mushroom like rocks. Okay, or this type of rocks. Okay, this is the effect of coastal erosion, right? Wave actions and all. So this is how the weathered rock looks. So I hope you have got a brief idea how the weathered rocks looks. Okay, then we'll see what are the points to be discussed in weathered rocks. So weathered rocks, as I told you, they hold a good quantity of groundwater. Why? The reason I told you, because it will have openings, because it has undergone weathering, it becomes weak, it becomes loose, and that is why the water gets or water percolates into the ground very easily and quickly. So the zone of groundwater saturation is stopped by the water table. So water table you can see in the weathered rock. So some predict weathering in only the acidic or oxidizing upper zone, but you will find weathering in the base of the saturated zone also, because of the process called hydrolysis, as in case of the limestone rocks. Then this weathering products, they must be removed if the reaction is to continue in the upper groundwater zone. So here weathering products, that is the broken rock materials, whatever are formed because of the weathering, they have to be removed if the reaction is to continue in the upper groundwater zone. So they are washed away by water. Okay, and in the lower zone what happens, the chemical diffusion removes the weathering products. So rock will break down, and those broken rock fragments, they are removed in the lower zone by chemical diffusion. Okay, chemical process, and removes the weathering product from the weathering front to the zone of mobile water. So all the weathered material, they are removed by chemical diffusion, and the groundwater moves in with a better flow. So since the deep weathering profiles may be tens of meter thick, the temperature at the ground surface does not affect the temperature at the depth. So what is given here is, since the deep weathering profile may be tens of meter thick, okay, whatever may be the thickness up to which the rocks have undergone weathering, that will not affect the temperature, okay. So temperature at the ground surface does not get affected, okay, as the depth increases. It will remain same. So groundwater percolates downward through the regolith. Regolith is the soil, topmost soil, which is the layer of weathered rock. Okay, ultimately end product of weathering is what? The soil. So alluvium, colluvium and soil, these are the different soils, okay, based on the grain size, to the fractures in underlying bedrock. So water will move downward, or it will percolate downward through this weathered rocks, okay, and up to the bedrock. So the water which moves from highland recharge areas to the discharge areas like springs and the streams at the lower altitude. So how these water will come on the surface is, the groundwater, it will follow the slope. It will move from highland recharge areas to the discharge areas where the areas are low lying, and through the springs and the streams at the lower altitudes, this groundwater will come on the surface. So these limestones are the soluble rocks, as I shown you in the last figure. These are the more soluble rocks which are acted upon by water, which is charged with carbon dioxide, and because of this it gets reacted with it, that is calcium carbonate, and CO2, that is carbon dioxide. The reaction will take place. So this forms the large interconnected openings like sinkholes, like then solution channels, cracks, etc. are formed because of the reaction of the water, which is rich in carbon dioxide, in the limestone. So these provide the space for water and its movement. So the limestones, they are considered as the best aquifers with excellent yield of water. So you will get a very good yield of groundwater in case of limestone region. So I hope you have understood what are the weathered rocks, how they show the presence of or occurrence of groundwater. Next we'll see how the groundwater occurs in hard rock. So as we all know, hard rocks are they will not have openings, primary openings as far as, okay. So primary openings are what? The primary openings are the openings which are there from the formation of the rocks, okay, and secondary openings are after the formation of rocks. The rock will undergo some processes and the openings are created, so that is called as secondary opening. So in hard rock, primary openings are very less, very rare, but when this hard rock like granite, you can take example of a granite or a gneiss, okay, so these are considered as hard rock. But when these hard rocks, they undergo weathering, when they form cracks, okay, you can see in the two first images, you can see there are number of cracks through which the water is percolating downward, right? So here you can see the cracks, okay, through which the groundwater percolates into the ground. So here also you can see the water bearing fractured system, okay, and this water, when it comes in the low lying areas, in the form of streams or springs, it will come on the surface. So actually fractures you can see on the rocks like this, the cracks. Okay, this is again showing the fractures, okay, or joints you can call them. Okay, so these are all the fractured rocks. These are actually hard rock, but because of the weathering and other processes, they have undergone or they have formed the different types of cracks. So hard rock, so these are the crystalline rocks like igneous and metamorphic rocks. Igneous rocks like granite and metamorphic rock like gneiss, they are usually hard and compact. The rocks like granites, quartzites and hard schist, they are usually impermeable, means it will not allow the water to percolate downward. Why? Because of their texture, because they are very hard. The texture is not favoring the water to percolate down, and they do not form good aquifers. The rocks, hard rocks, they are not the good aquifers, but the weathered, the disintegrated and the fractured rocks with the interconnected cracks or the joints or the faults and the shear zones below the loose permeable product of the weathering form the excellent aquifers to a depth of up to 30 to 50 meters. So what is explained here is actually these are the hard rocks, they are not the good aquifers, but if they have cracks, if they have undergone some processes, okay, then these, when they have undergone weathering, when they have disintegrated, when they have undergone fracturing, okay, fractured rocks with the interconnected cracks or even the joints, okay, or the faults or the shear zones. Shear zones are also the type of a crack below the loose permeable product of the weathering. They form the excellent aquifers up to a depth of 30 to 50 meters. So they are characterized by insignificant primary porosity. Means what? The primary porosity is the porosity which is there from the formation of the rock, okay, from the beginning. But here in such hard rocks, the primary porosity will be absent, and even the primary permeability. Pores means opening, and when these pores are interconnected, when the water flows through those pores, we call it as permeability. So due to weathering and fracturing, such rocks contain secondary porosity and permeability, which is not constant in every location. That again depends upon how much is the effect of weathering. Based on that, the rocks show the different secondary porosity and permeability. Then these igneous and metamorphic rocks, they fall into this group because the hydraulic properties of these rocks, they are mainly controlled by secondary porosity and permeability. So whatever hydraulic properties these hard rocks show, they affect the they are because of the secondary porosity and secondary permeability. So the main source of generation of porosity in hard rocks are the rock discontinuities, which are caused due to many factors. Like, so here the reason for formation of cracks is given, that is because of the tectonic stress, okay. During tectonic activities, the rock might have undergone the stresses, and that has resulted into formation of cracks. Then residual stresses, contraction and cooling, even the desiccation, unloading and weathering. Unloading is removal of the top layer because of the weathering, results into bottom layer to split. Okay, so that is called as unloading and weathering. So all these processes, they produce the secondary openings in the hard rocks. So the main rock discontinuities are foliation, that is the layering of the rocks. Like in case of granites, okay, we can see the rocks can split into layers when you remove the top load. That is a type of weathering, that is unloading. Okay, and the fractures or joints are formed in the rocks. Okay, then faults and lineaments are again the cracks which are extending for a longer distance. So all these are the main discontinuities which are seen in the hard rocks, and that is why they also become a good aquifers. So although the fractures and other discontinuities, they are most important factors which contribute the hydrogeological properties of the hard rock, some discontinuities like faults and dikes, they may act as a barrier to the groundwater flow. Means what? Where sometimes wherever there is a dike is a igneous intrusion into the rock, that is a hard again, so it will cause it is like a wall like structure, so which will not allow the water to percolate on the other side. So that is why it is called as it act as a barrier, the dikes. And sometimes fault also act as a barrier because there is a displacement of the rocks, so there is a discontinuity in the rock strata, right? So sometimes what happens, one side of the fault, okay, it will faulted rock, it will have the openings, but other side will not have the openings. There is a gap, okay, and because of that it will not be a continuous flow, and that is why the sometimes the faults and the dikes, they act as a barrier to the groundwater flow. Then we'll see the third type, that is the occurrence of groundwater in stratified rocks. So stratified, the meaning of the stratified is stratification, means layering. In this image you can see there are n number of layers, right? So these layered rocks are usually the sedimentary rocks, because we all know how the sedimentary rocks are formed. Each layer is it will tell you one history of what all the sediments, each layer will have different composition, different time of formation. Okay, so all these affect the groundwater percolation. So here the stratified rocks are what? They are the layered rocks. So usually sedimentary rocks are layered rocks, but the igneous rock, the one and only igneous rock, that is basalt. Here in the first image you can see it is from Mahabaleshwar, right? So this is showing layers, okay, but these layers are not the sedimentary layers, they are the lava flows, right? Whenever there is a volcanic eruption, the lava comes on the surface and it starts flowing, okay, and after consolidation of that lava one above the other, okay, that also shows the layered rock. So only basalt shows layering. Basalt is a igneous rock, okay, because it is a volcanic origin, that is it is formed by lava, but rest all are the sedimentary rocks, which are like sandstone, not limestone, sandstone, shale, okay, the conglomerate, breccia, all these are the examples of the sedimentary rocks. So these are formed by sediments and they also form layer by layer, so we call them as stratified rocks. So stratified rocks are the layered rocks, okay. So here in the first image you can see the grains, okay, here the grains are present, they are just weathered, okay, the rock fragments of different minerals, okay. So individual grain, it after the disintegration, okay, after disintegration or breaking of the rock, the sediments will be like this, they are spread, okay. Then once they get buried into some basin, it may be a oceanic basin or a river basin, what will happen is the compaction take place. So after burial, from all the side the sediments get compacted, means they come closer and closer. So what happens, the pore spaces you can see here, the pore spaces, the openings or the gap in between the sediments, right? So they are present here in more amount, but here because of the compaction the porosity decreases, okay, the pore spaces decreases because the grains come closer to each other in the compaction process. So after compaction, what happens, the cementation occurs. That is, cementation is what, there will be generation of some sort of chemicals like which will bind all the grains together, okay. Like here in this figure you can see all these pore spaces, they got filled by the cementing material, which is like a binding material which is combining all the grains together. So water, the water containing dissolved ions, okay, that will percolate into these pores and it will deposit that, and it will bind all the grains together, like iron, silica, all these act as a binding material for these sediments which are broken rock fragments. So cementation and compaction, it will reduce the porosity. So stratified rocks, they are layered rocks, okay. So here in the next image also you can see they are well sorted sediments, okay. All the grains are rounded and they are of same size almost, so the porosity is more, okay. In the second image you can see there are bigger particles also and there are smaller particles also, right? So smaller sediments, so what happens, this reduces the porosity. Poorly sorting sediments or poorly sorted sediments, the porosity will be less because the whatever bigger pores are there, they the smaller fragments, they get accumulated in the gaps and it will be like less space for water, right? So here if it is poorly sorted, the porosity will be less, right? Then these are the porous sediments wherein the groundwater flow very easily, right? Then in consolidated sediments, when it converts into a rock, there also the porosity will decrease because the grains come closer to each other because of the compaction, okay. Then dissolution of the rocks, that is the solutions when they travel through the rocks, okay, the rocks start dissolving and this will form the cracks, okay, and through these cracks the water again flows later, right? Then even same happens with the fractured rocks. So fractured rocks again, they show they are the good aquifers because the water will percolate through those cracks, okay. So this is how the stratified rocks looks. So in each layer you will find all these porosity and permeability factors which will affect the occurrence of groundwater. So in the stratified rocks are layered rocks. So most of the sediments, they are deposited in layers, okay, or beds that have been distinct grain size, then sorting and the mineral composition. So each layer in sedimentary rock will have different grain size, different sorting of the grains, and even the mineral composition will differ. So where adjacent layers differ in one of these characteristics or more, so the deposit is said to be stratified, and its layered structure is referred to as stratification. So layering is called as the stratification. Then these sedimentary rocks are formed by deposition of the materials, usually under the water, from lakes, rivers and the sea, and rarely from the wind. So most of the deposition takes place because of the water, under the water, in the lakes and the rivers, or into the sea. So the deposits formed by wind are very rare. In unconsolidated rocks, that is where the cementing material has still not played a role, right? So they are not consolidated, they are not compacted together. The granular material like sand and gravel, they have the voids or the spaces between the grains are more. So as in the previous figure I have shown you, if the voids are unconsolidated, if the fragments are unconsolidated, voids will be more, that is openings or the pore spaces will be more. Okay, and these may become consolidated by compaction and the chemically by cementation to form typical sedimentary rocks such as sandstone, limestone, shale, with much reduced voids between the grains. So as the rocks gets consolidated, what happens, the grain size, the grains, they come closer to each other, and as a result what will happen, the porosity will decrease after the cementation and compaction. So what are the factors which affect these sorting or these sedimentary rocks is the degree of sorting, whether they are poorly sorted, whether all the grains are equal in size, or they are some grains are bigger, some grains are smaller. So that is called as degree of sorting. Then packing arrangement, whether they are square or rhombus, okay, or rectangular pattern. So the porosity will be more in square packing. Okay, like square packing is packing is like this. This is the square packing. So here the porosity will be more, and here the porosity will be less, that is the rhombic pattern. Okay, you can see. So this is called as packing arrangement, square or rhombic. Okay, so the porosity of the individual classed porosity, then amount of cement already filling up the void spaces. Okay, so how much the cement is filled in these pore spaces, these are all the factors which affect the stratified rock properties. Okay, then this the grain size, or the size of the grains, that does not directly affect the porosity, but some shale or shale is a sedimentary rock which is made up of fine grained clay size material, clay. Okay, so they can actually have the porosity up to 90% open spaces. Okay, however extremely fine grained rocks usually are they make the poor aquifers. So if the grain size is very fine like clay, the porosity will be very less. So sandstones, sandstone is a rock which is formed by sand size particles, that is sand. So they form the good source of groundwater depending on their, again, the texture, whether it is coarse grain, fine grain, okay, degree of sorting. So sandstones are highly permeable with large openings like joints, bedding planes. Okay, so when they are folded into a syncline, they form an artesian aquifer. Means what? uh, the rocks are layered, okay, and when they get folded like this in the syncline fold, okay, I hope you remember this folding of the rocks, okay, because of the pressure acting on the rock, what will happen? The rocks undergo folding, and this type of syncline fold, okay, that act as a good aquifer, wherein you can expect the artesian aquifer, okay, because the water is flowing, and if you dig a well here in this aquifer, what will happen? The water will come automatically on the surface, that is called as artesian aquifer. So the sandstone, they form the good source of groundwater depending on their texture, okay. Then sandstones are highly permeable with large openings like joints. So joints are the cracks. So usually in sandstone you find the different types of joints, like you can expect the cuboidal joints, or there are big cracks, like in case where you might have seen in Badami caves, okay, they are all made in they are all in sandstone. So there you can see the big cracks in between, right, like a valley, right. So these big cracks, they are called as joints, okay. They differ again in size, even the small 1 meter also, or 1 centimeter also, if it is a crack, we call it as a joint. So joints again, they differ, there are different types of joints, okay. So they have a very good control over the percolation of water, and they play an important role in occurrence of groundwater. And when these type of rocks, they get folded into a syncline fold, that is like this, okay, like a basin, they act a very good reserve for water, that results into artesian aquifer. Then some volcanic rocks, as I shown in the figure, like basalt, which are highly permeable because of their interconnected weathered zones, okay, because weathering, the basalt undergoes weathering very quickly, okay, and even it will have primary openings like vesicles, because it is formed by lava, I told you, right. When the lava comes on the surface, the gases which are present in the lava, they escape and they leave behind the pores on it, that we call it as vesicles. So vesicles or cavities, and even columnar joints, you might be remembering, okay. Columnar joints is commonly seen in basaltic rocks. So these are again the different types of joints, okay. Fractures and other networks are seen in the rocks like basalt, which is a you can call it as a stratified rock, because it is formed in layers. They act as a good aquifers. Then large quantity of groundwater moves, and it is collected in such type of rocks, and it is extracted through the open wells or the bore well freely, okay. So this is how the stratified rocks, the groundwater occurs in the stratified rocks. So we have discussed now the occurrence of groundwater in different terrains, like how it occurs in hard rock, okay, then weathered rock, and how it occurs in stratified rocks. Thank you.